Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, our topic is about food, or the food recipe to be more precise. This topic is based on a tech blog written by data scientists from New York Times team with the title How the New York Times Cooking Team Makes Personalized Recipe Recommendations. I'm going to break it down from both a business and data science perspective. Now let's get started. On the business side, the New York Times is a publication company, and it offers diversified contents for customers so that they can stay subscribed. Cooking is one of the sections inside its subscription service, where it has its own home page and also dedicated apps. And there are tens of hundreds of recipes in their catalog. From the cooking perspective, it's very important to present recipes that are well customized and personalized for the customer's needs and interests. So that's where the recommendation algorithm is needed. Meanwhile, people have diversified needs for different recipes. And for example, sometimes we are looking for the right dessert in a season. Sometimes we may be looking for healthy selections. There is not just one perfect recommendation which is needed, but also for different scenarios, there need to be relevant recommendations to be surfaced up. And those recommendations are what the team put as different carousels to be presented on the homepage or inside the mobile app. That's a reason various type of recommendations is used in a system, and that is a very important lever to keep customers engaged with the contents and be happy with the service so that they can continue subscribe to the service. Okay, now we are very clear about the business side of the need. Let's shift gear to the data science side. First, about the general flow of how the recommendation algorithm works. There are in general two steps involved. The first one is to define a pool of eligible contents to recommend to users. For example, if the carousel selection is about desserts, then you want to only put dessert recipes in the pool for future ranking. Step 2 is to use a ranking algorithm to make the rank items in the pool. There are different ranking algorithms people can choose, from the simplest one, like the most popular items, or some more advanced ones. Now we know the general two steps of the ranking flow. Let's take a look at one key tools involved into the recommendation algorithm, which is the text embedding. A recipe can be represented as written out text to describe the recipe. There is a name about the recipe, the ingredients, and also the steps to prepare the food. But it's impossible to put a text into a recommendation algorithm. Anything in the algorithm should be represented by numerical values or numerical vectors. The text embedding converts the text description about the recipe into a fixed length vector embeddings. The dimension on embedding vectors sometimes have physical meanings. Let's say for different recipes, if one dimension is related to the sweetness of the food, then you will see recipe about the orange chicken. On that specific dimension, the embedding, the value would be pretty high. The same thing happens for an egg tart. It is sweet. So on that specific dimension, the value would be very high as well. Embedding can be used to measure the similarity between two recipes. Because they are represented as a vector, so we can introduce mathematical calculations to make the embedding calculation be representing the recipe similarity. And the way to use here is a cosine similarity. Basically, you're applying a cosine function over two embedding vectors, then you get a numerical number. The closer that number to 1, then it's saying the two recipes are more similar. And there are different ways to implement the embeddings. The team leveraged a pre-trained sentence transformer model for the purpose of generating embeddings. That's because, based on their different testing, they find this embedding has the best performance of engagements. So, using this text embedding plus the cosine similarity calculation, the team built the carousel to power the recipe recirculation service, where after a user viewed through one recipe, there are some similar recipes to be recommended, and that is where the recommendation service is used. Now we see the power of text embedding. We can make an extension of this approach to have the embedding representing the user as well. The way to do that is to look at historical engagements of the users with the recipes. For example, we can look at a user's historically saved recipes and take an average version of each recipe's vector embeddings. That could be a reasonable representation of the user as well. So at that moment, if you want to compare a recipe's similarity with a user's interest, then you can use a recipe embedding and user embedding's cosine similarity, and then you can get the result. Now we know more about the embedding used to represent each recipe and each user. Let's take a look at the ranking algorithm. The ranking algorithm referred in this blog is called contextual multi-armed bandit algorithm. What is a bandit? A bandit is a reinforcement learning algorithm that suggests the best decision among a list of options in order to maximize a specific reward. In the case of the recipe recommendation, the best decision is which article or which recipe to recommend. The list options are the pools of contents or recipes that can be recommended in a specific place. By saying maximize a reward, the reward can be defined in a way like high engagement, like click-through rate. So that is how a bandit algorithm is used here. The concept of bandit algorithm originated from the gambling in the casino, where if there are multiple slot machines, you want to choose the right slot machine to put your money in there. That requires you to explore different types of the slot machines and then see which one may perform the best. And then you exploit from the ones which you find can give you the max reward. The bandit balances exploiting known high click-through rates contents with exploring new content. And over time, it learns what recommendations to make in order to optimize reader engagement. So that is why the bandit algorithm is used here. So if a bandit has no contextual features at all, then it will typically recommend only the most engaging articles or recipes to all users. So that is the algorithm which the team used to power the most popular this week product. But if the bandit takes consideration about the features of the content itself and the user, then that product will be more customized for the user. And this algorithm is used to power we think you will love product service for the team. Okay, to wrap it up, in this episode, we take a look at how the New York Times cooking team leverages embedding and bandit algorithms to power its various recipe recommendation modules. We share the business perspective for why multiple recommendation approaches are needed. We also deep dived into what is embedding and briefly talked about what is bandit algorithm. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.